Hi, Adam. Can you tell me your whole name?
My name is Adam Selker.
And what are you doing right here in this shop today?
We are working on our permeability tester, which it will use a pump driven by a screw drive to push and pull water through a stream bed and measure the pressure, and in doing so, it will determine how permeable the stream bed is to water.
Cool. And what's this machine doing back here that we're seeing?
This is a 3D printer. It has a hot nozzle right about there, which extrudes molten plastic, and the plastic solidifies, and as it moves and extrudes, it can build a working part. What that is printing right now is another one of these bits right here. This part.
And this is the screw drive that will push the device up and down
Yes.
to pump the water into the riverbed, right?
And this is the head of the pump right here.
That's
So
the
this will be
piston.
moving vertically.
Okay. And this 3D printer, it uses software, so it's being driven off of here. How much longer does it have to make that print?
It's got a little more than 15 minutes left.
15 minutes left. So it's putting on layers of plastic. How thick are those layers of plastic?
At the moment, they're 1/4 of a millimeter thick. However, I've tested it down to about 1/10 of a millimeter. It works reliably, maybe a little less.
And then the bed of that's heated, right? That holds the plastic in place better. And this has a little motor here that drives the plastic, right?
It's pulling off of this spool of plastic over here. That's the medium, the ink. And it pulls it up through here using a gear and a bearing squishing the filament. It pushes it through this Teflon tube down to the nozzle there where it melts it and squirts it out.
Okay. And tell me a little bit about making this machine.
Well, I built this machine based off of designs that I found online. It's called a Kossel. The original design was around this tall and something like this wide, and it didn't have these diagonal braces. I expanded the design a bit, printed all these printed parts on our school's 3D printer. So it's a printed printer, and pieced it all together. I have modified the design a little, but most of it is all free open source models online.
Great. And when you finish this device, are you going to publish it free and openly online?
That's the plan, yeah. The one we have at the moment has things like this piston head, which was turned on a lathe. Hopefully I'll build a 3D model for that. The goal, the ideal world, would be that any random person could go to a hardware store, pick up some parts, then print out the rest of them, and assemble the whole thing.
And talk to me a little bit about what you call parametric design. So if someone in England was using metric materials, where we use some inch materials, how would that parametric design work?
Well, the parametric designs, in particular the 3D models. Here's an example of one of the models. This is the part that's printing right now. And it's defined by this bunch of code. And so all of these parameters here define the various lengths and distances and thicknesses of that model.
Can you show the
And-
model?
Sure.
So that's what was being printed right now, and you can spin that around on the screen and stuff like that.
So if I wanted to change, for example, how thick this is, or for what width of aluminum extrusion it's made for, all I have to do is change a number in that program, and it'll
just
change it.
Rescales the whole thing. Okay. Hey, Adam, thanks very much, and good luck with your project.
Thank you.